So the next functional group is haloalkanes. So halogens are fluorine, chlorine, bromine and iodine. So we'll see the general formula of this. General formula of haloalkanes are CnH2n plus 1. This is alkyl group and X represents the halogen which we are adding it to the hydrocarbon chain by replacing one hydrogen atom. This is alkyl and this one is the halogens, fluorine, chlorine, bromine or bromine and iodine. The functional group is represented just by X. So that is the heteroatom which is going to be added, prefix. So you are going to put the name in the front, not at the back. So it is fluoro and then follows the hydrocarbon chain name, the number of carbon atoms. So fluoro, chloro, bromo and iodo for all this fluorine, chlorine, bromine and iodine. So we will see the first number. So when this N is the number of carbon atoms, if I take 1, yes, I want to write chloromethane. So 1, so 1, 2 into 1, 2 plus 1 is 3. So CH3. So after CH3 I am going to put one chlorine. So this is called, so one carbon atom is there, methane. So it has a chlorine. So I am going to write the name as chloromethane. The next one I want the fluorine for ethane. So I have to write the ethyl group, CnH2n plus 1. So C2H2, 2s are 4 plus 1, 5, C2H5, fluorine. So it is fluoroethane. Now, when I write the third one, the propane one, so from third, there is possible for changing the places of iodine. So isomers, the structure can be different. So we will see 2 or 3 isotopes from here, from third member of the carbon homologous series of these haloalkanes. So third one, CCC, it is C3H7. So in this, so 1, 2, 3, 4, 5, 6, 7. Here I am going to add iodo. So this is iodine. So iodopropane. Iodopropane. So I want to add now this iodine by replacing the hydrogen atom from the middle carbon atom. So if I have to write this, then I have to count the carbon atoms now. So 3 is the number of carbon atoms. So I will write the name before itself. For second carbon atom I am going to put iodine. So it is 2 iodo. So 2 represents the position of the carbon atom for which we are adding this iodine, the halogen. So this is C, and for this my intention is to add the iodine. Then I have another carbon atom. So 3 hydrogens, H. Then I will have a H here. So 4 valencies are filled, H. Let me check whether the formula is correct or not. C3, then 1, 2, 3, 4, 5, 6 and 7 hydrogen atoms, and C3H7 is correct. And I have an iodine. This is 2 iodopropane, 1, 2. So we will try one more isomer for this, 2 bromobutane. So 2 bromo. So I want the bromobutane, like if you can count from any side, if I count from that side. So the fourth one is butane. So I'll write the fourth one here. So this will be, so I'm going to start the counting from this, 1, 2, 3 and 4. So I'll add the bromine to this one. So Br here. So then remaining all with the hydrogen atoms, H. Then I'll have a H here, H. So hydrogen and then hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is correct. So 9 hydrogen atoms, C4H, 8 plus 1 is 9, C4H9 and Br. So bromine we have taken it to be the second one for second carbon atom. So the formula which we have got is the correct one. This is how you are going to write the nomenclature for the haloalkanes. So alcohols general formula CnH2n plus 1 alkyl group, then OH. So OH, CnH2n plus 1 OH. Then this functional group is OH group. This is called hydroxyl group or alcohol group, hydroxyl or alcohol. Then suffix we are going to get OL for alcohol, OL. So we will start with the first one, methane. Carbon number N is the number of carbon atoms N. So N is CH3 is the alkyl methyl. So then we have to add OH for this. So CH3 OH, methanol, ethanol. So second one is C2H, 2 2s are 4 plus 1 5, C2H5 and OH. This will be ethanol. Then third one, that is with 3 carbon atoms we have propanol. From here we have the isomers, so we can add the hydroxyl group either to the last one or to the middle one or the first one. So anyhow, for the first and last you are going to consider it as just propanol. So C, and this I am going to add this hydroxyl group here, and you are going to put the hydrogen to satisfy the valencies of carbon. So this is correct. C3, 1 2 3 4 5 6 7, C3H7 OH, that is propanol. Then the isomer of this is isopropanol, where we have the hydroxyl group for the second carbon atom. So another isomer C, C and C for the second carbon atom. So I am going to have the isomer here. This will be my OH group. Then I will put H, 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 H and 3 more H here. So that is isopropane, or I can write exactly for isopropanol, or exactly I can write for the second carbon atom you have the hydroxyl group, so it is 2-propanol. 2-propanol. The meaning of this is for the second carbon atom the alcohol or the hydroxyl group is attached. So the next one I will tell for butane, for butane and butyl alcohol, butanol. So I will write the normal butanol. So if you are writing the normal butanol, you are going to add OH to the last carbon atom. So 2-butanol, the second carbon atom. So we will write 2-butanol. 2-butanol. So I will start counting from this side. 1, 2, 3, 4. I will add to this second carbon atom. 1, 2, 3, 4. Second carbon atom, the OH group, alcohol group. So then remaining the valencies we are going to fill with hydrogen atoms. The free electrons are combined with hydrogen atoms. So it will be C4H9 OH. 1, 2, 3, 4, 5, 6, 7, 8 and 9 hydrogen atoms. That is correct. This is the correct structure of butanol. So this is about the nomenclature of the alcohols. So the aldehydes group. So in aldehydes group you have the general formula alkyl, CnH2n plus 1. Then CHO, that is the aldehyde group. So the functional group is C double bond O, then you have a single bond H, CHO. Then suffix you have at the end Al, so Al, aldehyde, Al. So we'll start with the first one. So very important thing in this aldehydes is it's a terminal functional group. You can't attach the aldehyde group in the middle, so you don't have structural isomers when we are following the members of the aldehyde group, family of the aldehyde group. So particularly for now, you are not going to have any structural isomers. So we'll start with the first carbon atom. One more important thing is when you are starting with the first carbon atom, so we are not including the alkyl group here. So CHO, in this one carbon atom is there. So it is CHO. So just H for this group. HCHO. This is methanol. We have to count the number of carbon atoms. We should not add one more methyl group to this, but H will make it as methanol. Methanol. Then from now we are going to add an alkyl group CH3 for this, CH3. Then we have the aldehyde group CHO, CH3, CHO. So 2 carbon atoms are there. It is ethanol. Ethanol, NaL. For the third one, propanol. So you have to add an ethyl group for this, where you will have C2 H2N plus 1, that is 2 2s are 4 plus 1, C2H5 CHO. This is propanol. So 2 carbon atoms plus 1 3, so it is propanol. Then the fourth for 4 carbon atoms, so there is already a carbon atom, so you are going to add propyl group to this, C3H7. 6 plus 1 is 7, C3H7 CHO. So 3 plus 1 4, it is butanol. Butanol. Then the similar way you are going to write pentanol, where you are going to add the butyl group C4H9CHO. That will be the pentanol. So this is about the nomenclature of the aldehyde group. So ketone, the general formula for ketone is CN. So you have 2 alkyl groups on both sides, and it will be the middle one, non-terminating one. It will be in between 2 alkyl groups. So I am going to write this one as CN H2N plus 1, then a ketone group C double bond O, then another alkyl group. So for this I am going to put CN dash H2N dash plus 1. So in between 2 alkyl groups there is a ketone, like they are joined by CO. So short representation, short form is R C double bond O, then R dash. This R and R dash represents 2 alkyl groups on either sides of the ketone CO. The functional group is CO. So C double bond O. Then suffix you are going to get one, O-N-E, ketone. O-N-E. So one more important thing is, so for ketone group, the minimum possible thing is you have the smallest alkyl group is methyl. So methyl on both sides, 1C on both the sides, and a ketone group has a C. So minimum possible is 3 carbon. The smallest member of the ketone group is with the 3, so prop. It is the prop, or we can say with the own propanone is the smallest ketone possible. So number of carbon atoms are 3. So a methyl group on this side and the other sides of this, CH3 CO CH3. So I am going to count the number of carbon atoms. 3 are there. It is propanone. Now what will be the butanone? So butanone, one group, it can be ethyl and the other one can be methyl 1. So I will write C2H5 this side, C2H5 ethyl, then C double bond O, then you will have CH3. So C2H5, 2 carbon atoms, 3 4. This is another ketone which is butanone. Butanone, O-N-E is very important. So you can put the C on that side also. Then also it is not at all, it is not an isomer. We can't frame isomer with butanone. So we will see an isomer with the pentanone by changing the position of the ketone group. So I will take the 5th one with 2 pentanone, and then I will try with one more pentanone. Let me see the 2 pentanone. So CH3, I will take a propyl group this side, propyl, and that side a methyl group. So CH3, then I'm going to take CH2, then CH2. So CH3, CH2, CH2. So this one I had a propyl group here. 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. C3H7 propyl group. Then I'll get ketone here, CO. Then 1 methyl group, CH3. So I'll put 1, 2, 3, 4, 5. So 5 carbon atoms. It is pentanone, and the ketone group is exactly at the second carbon atom. So it is 2 pentanone. One more isomer I'll try with the pentanone. So we will take the CO, the ketone group, to the middle one. So it becomes 3. So at this position, so you have ethyl group on either sides now. So it is 3 pentanone. So whenever I say the number, we are referring to that functional group. So for the third carbon atom, you have the functional group. So 3 pentanone. 3 pentanone. So 2 ethyl groups on either sides. So here also I am going to put only 5 carbon atoms. So CH3, CH2, C double bond O, and CH2, CH3. Very good. So wherever I count from 1, 2, 3, 4, 5 carbon atoms, that's perfect. And an ethyl group C2H5 this side, C2H5 that side. So it is diethyl ketone if you are taking the common name. Right now we don't go for common names. So for the third carbon atom you have the own ketone group. So it is 5 carbon atoms are there. So it is penta, and for the third one it is 3 one or 3 pentanone. So this is about the nomenclature of the ketone group. Carboxylic acids, the general formula is the alkyl one, CnH2n plus 1. Then you have the group COOH. So the functional group of the carboxylic acid is, you have C, a double bond with O and a single bond with OH. So that is how the structure of this functional group is, COOH suffix. So this one carboxylic, OIC, OIC, oic acid, that will be the suffix which comes at the end. This is the terminal functional group. You will not have isomers for this functional group as you go through the members in the alkane or hydrocarbon chain. You will not have the structural isomers for the carboxylic acids. Then one more important thing is, this group contains 1 carbon atom. So you directly don't join the methyl group to this. We have to include this carbon atom also while counting, that is nomenclature. The first with 1 carbon atom is, so COOH. So I'm going to add HCOOH. So this name of this is, since 1 carbon atom is there, methanoic acid. Methanoic, OIC, methanoic acid. Then the second one, now from now we can add the alkyl group. So methyl and then acid group, CH3 COOH, CH3 COOH. This is 2 carbon atoms are there, ethanoic acid. So about methanoic and ethanoic acids we are very familiar before. So in your 8th class or 7th class you have come across the acids and bases lesson, even in 10th standard. The second lesson is acids and bases there. And sting. So and sting is very painful because it injects formic acid. So formic is the common name of methanoic acid. So the name formicus came from the Latin word which means red ant. Formicus is a red ant in Latin. So then one more, acetic acid. This also vinegar. Acetic acid is present in vinegar. So vinegar in Latin, vinegar is called as acetum. So from there it was derived, acetic acid. The common names of these, formic and acetic. Formic acid, methanoic, and acetic acid for ethanoic. The third one, we'll see the third member. So 3 carbon atoms. So this is methyl. So I'm going for ethyl group, C2H5, COOH. Count the number of carbon atoms. 3 carbon atoms are there, so it is propanoic acid. Propanoic acid. So then the fourth, so I have to add some, that is 3C3H7, the propyl, then COOH. Count the number of carbon atoms. 3 plus 1, 4. This is butanoic acid. This is how it follows. Pentanoic acid by adding C4H9COOH. This is about the nomenclature of the carboxylic acids. Thank you very much, everyone.